Good morning.
Good morning, sir.
Good morning, sir.
In the previous class, we discussed about the refrigeration cycle, vapor compression refrigeration cycle. Is it visible? Any one of you?
Civil, sir.
So in the last class, we discussed about this refrigeration cycle, and also we discussed about this is a vapor compression refrigeration cycle, and also we discussed about the process vapor compression refrigeration cycle on PV diagram, TS diagram, and enthalpy entropy diagram. These are the two things important point. The processes available in the vapor compression refrigeration cycle are isentropic compression process, okay, are also called as reversible adiabatic process. And then here you see the 2 to 3 constant pressure heat rejection process in the condenser. Constant pressure heat rejection process in the condenser. And then H is equal to constant expansion process. Throttling process, enthalpy remains constant. H is equal to constant. And then here, constant pressure, heat addition process, evaporation process. So these are the 4 processes taking place in the refrigeration cycle. Okay. So first process, 1 to 2 is compression process, isentropic compression process. Entropy remain constant. Compression is isentropic compression. 2 to 3 is condensation process, but pressure remains constant here. See that. During the condensation process, heat is rejected to the surrounding medium. So constant pressure heat rejection process, condensation process. And 3 to 4 is expansion process in the expansion valve. Expansion valve is also called as throttling valve. Throttling process is constant enthalpy process. Constant enthalpy process is also represented as isenthalpic process. Enthalpy is heat, isenthalpic process. Okay. So constant enthalpy process. 4 to 1, evaporation process. Evaporation is, during the evaporation, heat is added, heat is absorbed by the refrigerant from the surrounding medium. So heat is added to the refrigerant. So constant pressure, here you see the pressure constant pressure heat addition process. So these are the processes taking place. And also I explained to you, this is nothing but saturated liquid line up to this point, doom. After that, here you see that the curve moves downward. This is saturated vapor line. So the topmost point is called the critical point. Critical point. So here you see that point number 3 is on the saturated liquid line. Point number 1 is on the saturated vapor line, dry and saturated vapor line. Point number 2 dash is also on dry and saturated vapor line. So when a point lies in between these two curves, liquid and vapor, then it is called a wet vapor. That means it contains liquid plus vapor. Point number 4 is wet vapor. It contains liquid plus vapor. Point number 1 dash is also liquid plus vapor. But this point number 4 is very close to liquid line, so it contains more liquid particle. Point number 1 dash is close to vapor line. Therefore, at point number 1 dash, more vapor particle is there. Okay, but it is wet vapor. Wet vapor, it is nothing but liquid plus vapor. Point number 2 is superheated vapor. That means the region just right side of this saturated vapor line is called the superheated vapor region. These regions are called the superheated vapor region. Okay. And similarly, suppose if a point is here, assuming that this line is extended, the point 3 is extended leftward. You are marking this point as 3 dash. Okay, assuming that point 3 dash is here or somewhere here. That means this region is called subcooled region or undercooled region. So when a point lies just left side of the saturated liquid line, that is called subcooled region or undercooled region. So, okay. So these are the important points. What even is subcooled or undercooled? That means the liquid is cooled. That means the saturated liquid refrigerant is cooled. Liquid refrigerant is cooled below the saturated liquid. Its temperature is cooled below the saturated liquid line. Okay. So these are the important points available regarding the property diagrams. Property diagram means pressure volume diagram, temperature entropy diagram, enthalpy entropy diagram. So this process is represented in the enthalpy entropy chart. I think one student switched on the mic. Amarnath. Okay. Here you see that the process 3 to 4 is constant enthalpy process. This is a y-axis is enthalpy value. Therefore, the process 3 to 4 is constant enthalpy line. So horizontal line is drawn. That means H3 is equal to H4. Okay. You know that is why in the enthalpy chart, this process 3 to 4 is horizontal. Okay. So like that you have to analyze and prepare. But what about the pressure during the enthalpy process? Pressure decreases from P1 to P2. Therefore, the point number 3 is on the line P1. Point number 4 is on the line P2. Pressure decreases. P2 is less than P1. So P3 is point number on pressure line P1. P4 is on pressure line P2. You check this. So like that, analyze the PV diagram and the TS diagram and the enthalpy entropy diagrams. Okay. So these are the refrigeration cycle, vapor compression refrigeration cycle processes that is represented in all the property diagrams. You know the cyclic process. Here the liquid refrigerant is converted into vapor refrigerant, and then vapor refrigerant is converted into liquid refrigerant again. Therefore, it is called a cyclic process. Okay. And also I explained to you. Here you see that the flow of refrigerant take place. So it is a steady flow system. Flow of refrigerant take place. Flow of refrigerant take place from the evaporator to compressor, compressor to condenser, condenser to expansor, like that. Therefore, work done during the flow process is given here. Work done during the flow process is V multiplied by change of pressure. Work done. Okay, when work input is given, here work input is given to compress the vapor refrigerant from dry and saturated vapor to superheated vapor. Work input is given. That means it is a power consuming one. Therefore, minus symbol is given because work is done on the refrigerant to raise its pressure from low pressure to higher pressure. So work is done. Power is consumed. Therefore, negative symbol. Okay. It is a flow, steady flow device. Open system. Therefore, work done equation is V into dP. Closed system, piston and cylinder element is P into dV, integral P dV. Here you see that pressure P1 to P2, integral V dP. Okay, V multiplied by dP. So these are the process. I already explained to you what is refrigerating effect. That means refrigerating effect is equal to what is refrigerating effect? Heat absorbed by the refrigerant from the surrounding medium. Okay. Here, these are the points given in the pH chart, pressure enthalpy chart. pH chart is pressure enthalpy chart, like the steam table chart, Molière chart. Pressure enthalpy chart is there. Okay. So what is this pressure enthalpy chart? Here you see that this represents the saturated liquid line. X is equal to 0, critical point. Okay. And this is the saturated vapor line. Saturated vapor line. Here x is equal to 1. Here x is equal to 1. So in between the saturated vapor line and liquid line and vapor line, this region is called a liquid vapor mixer. This region. So quality of refrigerant is given. Dryness fraction is given. X is equal to constant along this line. Maybe it may be x is equal to 0.2. This may be x is equal to 0.4, like that. Okay. And here you see that these are all the temperature lines. T1 temperature, T2 temperature, T3 temperature. So vertically downward, and then horizontal line, and then again curved line. So T3 temperature lines are marked like this. Vertically downward, and it meets the saturated liquid line, and then a horizontal line is given, and then curved line is also given. Okay. Curved line is given. Clean down on the fan. Matrani, you want to vandra? Okay. So, vertically downward line, horizontal line, and then curved line. So, these are the properties that is marked. Similarly, what is S is equal to constant? Along this line, entropy is constant. Along this line, entropy is constant. S is equal to constant. So, this curved line, X is equal to constant. Curved line. Okay. And here you see that V is equal to constant. Volume is equal to constant. Specific volume is equal to constant. This is also curved line. Here you see that volume is equal to constant. So these are the property values available in the pH chart of refrigerant. Refrigerant pH chart. I already told that there are many types of refrigerant, classification of refrigerant. Okay, each refrigerant has different chart. Each refrigerant has chart. Freon group of refrigerant has one chart. Ammonia refrigerant has another chart. Carbon dioxide refrigerant has another chart. So like that. Okay. So there are many refrigerant charts are there based on the refrigerant because their thermodynamic property varies. Okay, this is a type of chart is available at the end of the e-book. Saturated vapor line X is equal to 1 means 100% vapor. X is equal to 0 means 100% liquid. Okay. So the process is represented in the PV diagram, pH diagram, pressure enthalpy diagram. Compression is isentropic compression. So point number 1 is assumed that dry and saturated vapor. The vapor leaving the evaporator is dry and saturated vapor. Compression is isentropic compression. Okay. During the compression process, work input is given, power is consumed to raise the pressure from the low pressure P2 to higher pressure P1 condenser pressure. So pressure is increased from evaporator pressure to condenser pressure. So during the compression process, we know that entropy remains constant. All the processes are reversible. There is another name is reversible adiabatic process. Is called constant entropy process. So dry and saturated vapor is compressed to superheated vapor. Understand? Dry and saturated vapor is converted into superheated vapor. Therefore, the point number 2 is marked in superheated vapor region. That means this point is just right side of this dry and saturated vapor line. So this is superheated vapor region. This point is superheated vapor region. Okay. So temperature is T2. That is the compressor discharge temperature. This is the highest temperature. Compressor discharge temperature is the highest temperature. This is the condensation temperature. Condensation. Okay. Pressure remains constant here. First, the superheated vapor is converted into dry and saturated vapor. And then it is converted into liquid, saturated liquid. Point number 3 is on the saturated liquid. During the condensation process, heat is rejected to the cooling medium, air or water. Therefore, Q1 is outward. Q1 is outward. 3 to 4